Hello friends, welcome to Pravegaa Education. So here I am once again with the new question of the TIFR 2024. This question is basically from the polarization of the light and the question with the subtopic from the Malus Law. It's a question from the Malus Law. The question is, an unpolarized light of intensity 200 watt per meter square is incident on a set of two perfect polarizers arranged one behind the other. The question is, there is an unpolarized light. I have made the diagram also here. There is an unpolarized light whose intensity is given. I have taken the intensity I0, and this light incident on a set of two polarizers arranged one behind the other. Okay? So first polarizer is there and there is a second polarizer. The first polarizer had this transmission axis plus 55 degrees. So the question is saying this transmission axis, that is also called the pass axis, and this angle is nothing but what? This angle is 55 degree. Okay, this angle is 55 degree. So let's write it first. This angle is 55 degree. Okay, now with respect to the vertical, okay, and the second polarizer had the transmission axis of 100 degree, and this polarizer has the transmission axis of 100 degrees. Okay, these two I have mentioned here. With respect to the vertical, what is the intensity of the transmitted light? Means they are asking what should be the intensity of the light ray that will be emitted after the second polarizer. Okay, so let's discuss first the concept of the Malus law. And the Malus law states that when an unpolarized light incident on a polarizer, then basically what happens, it just reduces the intensity by the factor of the 2. Actual concept is when the unpolarized light or the circular polarized light passes through a polarizer, then its intensity become half. Okay, so here the incident light is unpolarized light, so after passing from the first polarizer, the intensity will be just simply I0 by 2. And one more thing, it will be parallel to the pass axis. If the pass axis is a 55 degree, then the emitted light which will be emit after the first polarizer will be parallel to its plane, and it will be plane polarized. Okay, whatever type of light basically you are hitting initially, it doesn't matter. The outcome of the basically the transmitted light after basically it will transmit from the polarizer, always it will be plane polarized, no matter which type of polarized light you are incidenting, right? So here, according to the question, there is unpolarized light, so the emitted light will be plane polarized, and it will be parallel to this along this path axis. Okay, and its intensity will be half. Now, again, this plane polarized light is passing through the second polarizer. Okay, and this polarizer is 100 degree from the vertical. So Malus law states that when a plane polarized light basically will pass through the polarizer, then the intensity will get changed, and the final intensity I am representing that by the I dash. This will be I cos square theta. I am taking the I because I am taking I0 by 2 as the initial intensity. I0, it will be basically I0 by 2 and cos square theta. Okay, this will be the final intensity after emitting from the second polarizer, because I0 by 2 intensity becomes the behaving as the initial intensity for the second polarizer, right? And cos square theta comes from the Malus law, because Malus law states that when polarized light or unpolarized light passing through the polarizer which has the path axis with the vertical at theta, then the emitted light as the intensity, and let's suppose denoted by I dash, as intensity I0 cos square theta. Okay, so this is a concept from the Malus law. Okay, it's a very important phenomenon, very important law, very important concept. Okay, so finally emitted light ray having the intensity I0 by 2 into cos square theta. Now the question arises, what should be the theta here? The theta can be 100 degree or something else. No, the theta cannot be 100 degree because it is at a 100 degree from the vertical. But This theta is the angle from the with respect to first polarizer, right? So first polarizer is already 55-degree alignment, and this 100-degree is with respect to the vertical. So basically the theta, theta will be nothing but 100-degree minus this 55-degree. So the theta will comes out 45-degree, okay? So this theta we have to take into the account. So let's put the value and we'll get our answer. What should be the final answer? This will be I is equal to I naught by 2. The I naught is going to 200 watt per meter square. So 200 by 2 into cos square theta. So cos square 45-degree. Cos 45 is 1 by root 2, right? And when we put this, the final answer will be 200 by 2 into 1 by 2, and the answer will be, intensity will be 50 watt per meter square, okay? That means after emitting from the second polarizer, the intensity will be 1 by 4th of the initial intensity. So this was a question from the TIFR exam. It's a very easy question, and it's a very important law actually in the NET exam, in the GATE exam, TIFR exam, in the JEST exam, right? In all the exam, basically the concept from the polarization of light is very often, if you see the previous year papers, okay? So option A is correct, 50 watt per meter square. Thank you so much.